Hello, I am Ahmed Rida Sekkat from LITIS lab of University of Rouen, and I will present you our work, the OmniScape dataset. As you know, omnidirectional cameras have significant advantages compared to perspective cameras, especially the large field of view. However, datasets of omnidirectional images dedicated to computer vision algorithms evaluations are not as available as those of perspective images. This is due to the time cost and human effort required to annotate ground truth images. For example, that's the reason why recent work on semantic segmentation of fisheye images of road scenes had been performed on perspective images to which a tangent transformation with several focal lengths was set to simulate different fisheye images with their corresponding annotations. The unpleasant effects of using a tangent transformation is that the field of view of these images is not comparable to the large field of view of omnidirectional images. The amount of information in a fisheye image is much more important than the one in images generated with this transformation. We can easily notice that pixels representing foreground object classes like person and vehicle, for example, are very less in fisheye images compared to transformed perspective images. Hence the interest to develop a more reliable simulation for omnidirectional images. So we propose a framework to generate omnidirectional images from a virtual environment using 360-degree cube map images and an omnidirectional camera calibration model. To create 360-degree images, 6 images are extracted in the 6 different directions. Using the appropriate omnidirectional camera model, each pixel of the omnidirectional image can be associated with a 3D direction on the sphere. We then compute the cube that presents the 6 images under the cube map projection. Using ray tracing, we construct a lookup table that stores correspondence between the omnidirectional image and the cube map image. It corresponds to the intersection of the 3D direction associated to each pixel in the omnidirectional image with the cube map images. Then we just need to affect to each pixel in the omnidirectional image the corresponding relevant information from the cube map image: texture, depth value, or label, depending on the modality, RGB, depth, or semantic segmentation. And here we can see the results of the mapping of the 6 images into the 2 kinds of omnidirectional images generated in this work, fisheye and catadioptric. To generate the dataset, we choose to use the calibration model proposed by Scaramuzza. It is a calibration model for omnidirectional cameras, considering the omnidirectional imaging system as a compact and unique system composed by a pinhole camera and a mirror. It allows to compute the intrinsic parameters of the omnidirectional camera. This means that it provides the relation between a given 2D pixel and the corresponding 3D vector from the point of view of the unique sphere. And this relation is modeled by a polynomial function where coefficients here A0, A1, A2, etc. are the calibration parameters. So we demonstrate the relevance of the proposed framework on 2 well-known simulators: Carla Simulator, which is an open source simulator for autonomous driving research, and Grand Theft Auto 5, GTA 5, which is a very high quality video game. The OmniScape dataset contains for each capture fisheye, catadioptric, and 360-degree stereo RGB images from the 2 front sides of a motorcycle with semantic segmentation and depth map ground truth, as well as the dynamics of the vehicle, namely velocity, angular velocity, acceleration, rotation, and position. The intrinsic and extrinsic parameters of the camera are also provided. The RGB images extracted are available in 15 different weather and lighting conditions, and 360-degree images are provided under cube map and equirectangular projection. We choose to configure our recording platform with stereo omnidirectional cameras on both front sides of a motorcycle because two-wheeled vehicles presents a challenging problem related to the specific dynamics of these vehicles, which is not similar to the dynamics of cars, for example. Motorcycles undergo rotations, yaw, pitch, and roll on the three axes. This makes the computer vision tasks harder due to the inadaptability of classical methods to orientations changes without a particular treatment. Here we can see, for example, some statistics on the rotations and also the distribution of pixels of all images in the dataset for both fisheye and catadioptric images. We can see that foreground classes are less presented than background classes, which is one of the main challenges of this kind of cameras in addition to the distortions and rotations in our case. Finally, here we have some additional modalities we added to the dataset. So currently we use the last release of Carla Simulator, to which we added new classes in the semantic segmentation as two-wheeled vehicles. We also generate instant semantic segmentation and 3D bounding boxes of vehicles and pedestrians. In complement to the images given in the paper and this presentation, more examples from Carla Simulator and GTA 5 can be found in OmniScape GitHub page, where you will also find a link to a form you can fulfill to receive the first release of the dataset. So if you are interested, please check out the repository, and thank you.